Problem number 32, calculator problem. A closed semi-cylinder is to have a total volume of 500 cubic feet. What radius will minimize the surface area? What the heck is a semi-cylinder? A semi-cylinder is a cylinder which has been cut in half lengthwise. What is a cylinder? A cylinder is a circle that has been three-dimensionalized. It's a circular prism. So if you take a circular prism and you cut it in half, it's going to look something like this. Like picture a semicircle, and then it's got a flat surface on top, something like that, and then there's kind of like a curved side of it like that. So this is that shape, roughly speaking. If we want to do this problem and minimize this surface area, we need to take this and we need to write some equations. We need to write the equation of the volume because we know that the cylinder will have a total volume of 500 cubic feet. So how do you find the volume of a prism? Volume of a prism is an area of the base times the length. So let's call that right there L, and then let's call that 2R. I'm calling that 2R because really what I'm saying is that I'm calling the radius R, okay? So that whole side there would be 2R. So if I want the area of the base is half of a circle. It's a semicircle. So the area of the base would be, if I could write, area of the base, well, it's a circle, pi r squared, but it's half of it, so it is 1/2 pi r squared, okay? So the volume then, volume is going to be the area of the base times the height or the length. So volume will equal 1/2 pi r squared L. And we know what the volume needs to equal. The volume needs to equal 500. So 500 has to equal 1/2 pi r squared times L. Okay, so there you have that. We're trying to minimize the surface area, which means we need an equation for the surface area. Well, surface area just means literally all of the areas of every surface. So if you think about the area of the bases, we have one base at each end. Each base is a half of a circle. So the area of both bases combined is a full circle. So we know that the area of the bases is going to be pi r squared. What else do we need? We need the area of that top rectangular piece. We know that top piece is included because it's called a closed semi-cylinder. So all surfaces are sealed. So we need to add to the area of the bases the area of that top piece, which is a rectangle whose dimensions are 2r times L. It's a rectangle. One dimension is 2r, the other is L, so 2RL is the area. The last area we need is the curvy bit. Curvy bit being this right here, which curves all the way around that semicircle to the other side. So if you could picture that, that's actually a rectangle that's kind of enfolded into a curve. And the length of the rectangle is L, but what is the other dimension of the rectangle? Well, it's whatever that circumference is of that curved edge on the semicircle. And it is a semicircle, so if the circumference of a circle is 2 pi r, then the circumference of a semicircle there would just be pi r. So this last bit needs to be pi r times L. So pi LR there, or pi RL, whatever you want to write. Pi RL. Okay. So we have a surface area equation, and we're trying to minimize the surface area equation, which means we need to graph the surface area equation. So I need to substitute because surface area equation has three unknowns: surface area, R, and L. So I need to use my volume equation and solve it for one of my variables. Which variable is easier to solve for, R or L? L is easier to solve for because you don't need to square root. So first thing I'm going to do is I'm going to multiply everything by 2 to get 1,000 equals pi r squared L. I want L by itself, so I'm going to take that 1,000, I'm going to divide it by pi r squared to get that L by itself. I'm going to now substitute that everywhere I see an L. So surface area will equal pi r squared plus 2r times my expression for L, which is 1,000 over pi r squared, plus pi r times L again, which again is 1,000 over pi r squared. Let's simplify some things. I've run out of room. I can't go down any farther, so I'm going to write over here. Surface area equals pi r squared plus, let's simplify this thing. I have an r in the top, canceling one r in the bottom. I have a 2 times 1,000, so I have pi r squared plus 2,000 divided by pi r. Plus, let's simplify this one now. I have an r on top canceling with an r down there. I have a pi on top canceling with my pi down there. So I'm just left with 1,000 divided by r. So now I want to graph this thing. So go to y equals and hit pi x squared plus 2,000 divided by parentheses pi x, close parentheses. If you don't have parentheses, you're going to get the wrong answer, plus 1,000 divided by x. Window, I'm going to go x min 0. I'm going to go x max. Honestly, I don't know what it should be, so I'm just going to try 10 for an x max, and I'm going to do a zoom fit. Zoom 0. I'm going to see what happens. I'll adjust it if I need to. And it looks okay. With that window, you get something that looks like that. And you can't really see it start to come back up yet. And what we want to see is we want to see something that looks like that. Because if it looks like that, we'll be able to easily find that minimum. So I'm going to give myself more x. I'm going to go x max, maybe send it up to 20. Now do a zoom fit again. It will fix my y values for me. And does it look better this time? Yes, we can start to see my graph come back up. It's not drastic, it's like that, but it is coming up a little bit. So we will be able to find our minimum with the calculator. So second, calculate minimum is option 3, left bound 0, right bound 20, guess, hit enter. It will jump you straight to x equals 6.386. And so the minimum surface, what radius will minimize the surface area? Well, a radius of 6.386 feet will minimize the surface area.